Hello everyone, welcome to Infinity Learn. Let's discuss unit test 2 physics section. So let's start with question number 1. A gas deviates maximum from the ideal gas laws at. So correct answer is option 4. At low temperature and high pressure, the gas deviates from its ideal gas behavior. Second question is, in this cycle we need to find which of the following options are correct. So you can see that work done is negative. Delta E will be 0, right? Because initial and final states are same. And last one is the first law of thermodynamics. So you can use Q is equals to delta E plus delta W, right? So if work done is 0, delta E is 0. If work done is negative, delta E is 0, then you can say that Q is also 0, which is option 1. Next is, if two balls of the same metal weighing 5 gram and 10 gram strike a target with the same velocity, the heat energy so developed is used for raising their temperature alone, that the temperature will be higher for. So, in this case, we know that this half mv square will be converted into ms delta theta. M will cancel this m. So, delta theta, that is the change in temperature, will be v square upon 2s. Now, this change in temperature is independent of the mass. It depends on velocity and s. So we have same method. So s will be same and velocity is also same. So delta theta, that is the rise in temperature, will be equal for both the balls. So correct answer is option 3. Next is question number 4. An engineer claims to have made an engine delivering 10 kilowatt power with fuel consumption of 1 gram per second. The calorific value of the fuel is 2 kilocalorie per gram. How is the claim of the engineer? So if you look at the input, it will be 1 into 2 into 1000 into 4.2 joule, and output will be 10 into 10,000 watt joule per second, right? So in this case you can see that output is greater than input, so this claim is invalid. I hope this is clear, right? Excellent. All right, so next is question number 4. 1 gram of steam at 100 degrees Celsius is mixed with 4 gram of ice at 0 degrees Celsius. The final temperature of the mixture is. So the steam will convert itself into water at 100 degrees Celsius, and after that its temperature will decrease. So heat is released by the steam. This heat will be gained by the ice in order to melt itself, as well as in order to increase the temperature of the water from ice, right? So heat released is equals to heat absorbed. So 1 gram of steam, so it is m into L, 1 into L for evaporation is 540, plus 1 into 1 into, let's say, temperature is T. So the temperature of the steam is from 100 minus T, and this heat released will be absorbed by the ice. So it is 4 into 80 plus 4 into 1 into temperature will change from 0 to T. So T minus 0 is the change in temperature. After solving this equation, you'll get the value of T as 64 degrees Celsius. Next is, a refrigerator absorbs 2000 calories of heat from ice tray. If the coefficient of performance is 4, then work done by the motor is. So basically coefficient of performance is equals to QH upon W. So W will be QH, that is 2000 calories. So it is 2000 into 4.2 joule divided by coefficient of performance, that is 4. So it will be 500 into 4.2, which is equals to 2100 joules. Next is question number 7. Two masses, M1 is 5 kg and M2 is 4.8 kg. Type 2 string are hanging over a light frictionless pulley. We need to find the acceleration of the system. So acceleration will be M1 minus M2 G divided by M1 plus M2. So it will be 5 minus 4.8, G is 9.8 divided by M1 plus M2, that is 9.8. So correct answer is 0.2 meter per second square. That is option 1. Question number 8. A body is projected horizontally from the top of a tower. When the body strikes the ground, its velocity is v, and the direction of motion makes 30 degree with the horizontal. The velocity of projection is. So final velocity when it strikes the ground is v, and its direction of motion is 30 degree with the horizontal. So we know that for a projectile motion, the horizontal component of the velocity will remain constant. So basically, v cos 30 degree, which is v root 3 by 2, will be your correct answer. Next is water can be made to boil without heating. Yes, by decreasing the pressure, we can make water boil. So this is true. Boiling point of water is lowered by decreasing pressure. Yes, up to triple point you can decrease the value of boiling point by decreasing the pressure. So statement 1 and 2 both are true. Next is question number 10. Two identical rods AC and CB are made of two different materials and the thermal conductivities are in the ratio 2:3. So you can assume first one is 2K and second one is 3K. They are kept in contact. This end is at 100 degrees Celsius. This is at 25 degrees Celsius. We need to find the temperature of the junction C. So you can write the equation for the rate of flow of heat, because the heat which is passing through this will also pass through this, right? So you can write it as 2K A delta theta, that is 100 minus Tc, divided by L is equals to 3K A Tc minus 25 divided by L. So after solving this equation, you'll get the value of Tc as 55 degrees Celsius. Next is question number 11. A cylindrical rod having temperatures T1 and T2 at its end, the rate of flow of heat is Q1 calorie per second. If all the dimensions are doubled, keeping T1 and T2 constant, then the rate of flow of heat Q2 will be. So Q1 is Ka delta T divided by L. So K and delta T is kept constant. Only area and the length is changing. So if all the dimensions are doubled, that means radius is doubled. So area will become 4 times and the length will become 2 times. So basically this is 2 times Ka delta T divided by L. So this is your 2Q1, which is option 2. A metal piece is heated to T Kelvin. The temperature of the surrounding is T Kelvin, small t Kelvin. The heat loss to the surrounding due to the radiation is proportional to. So according to Stephen's law, this will be proportional to. You can write it as this will be proportional to T power 4 minus small t power 4. So correct answer is option 2. Next is question number 13. The surface temperature of the sun, which has maximum energy emission at 500 nanometer, is 6000 Kelvin. The temperature of a star which has maximum energy emission at 400 nanometer will be. So we can use Wien's displacement law. So it is lambda m into T is equals to V, which is equals to constant. So you can equate lambda m into T for both the stars. So it will be 500 nanometer into 6000 Kelvin is equals to 400 nanometer, and let's say temperature of that given star is T. So this will cancel this. So we have T as 7500 Kelvin. Question number 14. Consider the following statements. Water cannot be boiled inside a satellite by convection. In gravity-free space, convection cannot take place. So yes, correct. A statement is true. In weightlessness condition, natural movement of heated fluid is not possible, which is also true. So correct answer is option 1. Both A and B are true. For higher temperature, the peak emission wavelength of a black body shifts to lower wavelength. Yes, lambda m is inversely proportional to T. So if temperature is high, lambda m will be low. Peak emission energy of a black body is proportional to peak emission wavelength of a black body is proportional to fourth power of its absolute temperature. No. This is the relation. So this statement is false. 1 is true, B is false. So correct answer is option 2. The volume of a gas changes from 2 liter to 10 liter at a constant temperature. The change in internal energy will be. Change in internal energy is directly proportional to change in temperature. There is no change in temperature, so it will be 0. Correct answer is 4. A mixture contains N1 moles of a monoatomic gas and N2 moles of a diatomic gas, and gamma is 1.50. The ratio of N1 is to N2 is. So gamma mixture is given by N1 Cp1 plus N2 plus N2 Cp2 N2 Cp2 divided by N1 Cv1 plus N2 Cv2. By putting the values of Cp and Cv of monoatomic and diatomic gas, you get the N1 is equals to N2 relation, right? So correct answer will be option 1, which is 1 is to 1. Next is, if the RMS velocity of oxygen molecule at a certain temperature is zero point 0.5 kilometer per second, the RMS velocity of hydrogen molecule at the same temperature will be. So Vrms is inversely proportional to under root m. So V for hydrogen divided by V for O2 is nothing but m of O2, that is 32, divided by m of hydrogen, that is 2. So it will be under root 16, which is 4. So V hydrogen will be 4 times V of O2, that is 0.5. So 2 km per second is the correct answer. Gas at a pressure P0 is contained in a vessel if the masses of all the molecules are halved and their speeds are doubled. The resultant pressure P will be equal to. So pressure is directly proportional to mv RMS square. Fine. So masses are halved. That means it will be m by 2 and Vrms doubled. So it will become 4 times Vrms square. So it is nothing but 2 times m Vrms square. So pressure is directly proportional to m Vrms square, but it is becoming 2 times after changing the parameters, given parameters. So new pressure will be 2p0, which is option 2. A box containing food supplies is released from an airplane moving horizontally at a height of 490 meter with a velocity of 180 km per hour. The box will move horizontally while falling just before striking against the earth. So this is range, that is equals to u under root 2h by g. U is 180 into 5 by 18 meter per second. H is 490 divided by G is 9.8. So after solving this equation, you'll get your answer as 500 meter. Option 3 is correct. Question number 21. A particle is thrown with a speed u at an angle alpha to the horizontal. When the particle makes an angle beta to the horizontal, its speed will be. So horizontal component of the velocity will be constant in this projectile motion. So u cos alpha will be equal to v cos beta. So v will be u cos alpha upon cos beta. So it is u cos alpha sec beta, which is option 2. Next is question number 22. A monkey is descending from the branch of a tree with a constant acceleration, and the maximum tension in the string will be 75% of the weight of the monkey. We need to find the minimum acceleration. So it will be mg minus 75% of mg, that is 3 by 4 mg, that is equals to ma. So a will be g by 4, which is option 3. A spring balance is attached to the ceiling of a lift. A man hangs his bag on the spring and the spring reads 49 Newton. That means the value of mg is 49. So m will be 49 divided by 9.8. Now lift is stationary, then reading is 49. But if lift moves downwards with an acceleration of 5 meter per second square, the reading of the spring balance will be. So in this case, reading will be m of g minus a. So it will be 49 divided by 9.8 into g is 9.8 minus a is 5. So approximately this answer will be 24 Newton, which is option 1. Next question is 24. When forces F1, F2 and F3 are acting on a particle of mass m such that F2 and F3 are mutually perpendicular, then the particle remains stationary. If the force F1 is now removed from the acceleration of the particle will be. So we know that F1 plus F2 plus F3 vector is equal to 0. Now if force is removed, F1 is removed, net force will be F2 vector plus F3 vector and divided by mass will give you what? Acceleration. But using this equation, you can write F2 vector plus F3 vector as minus F1 vector. So it will be minus F1 vector divided by m. So magnitude will be option 1, F1 upon m. Next is question number 25. Unit vector in the direction of the resultant of vector is. So resultant will be a plus b vector, that is minus I cap plus 2j cap plus 3k cap, and unit vector will be divided by its magnitude. So it is minus 1 whole square plus 2 square plus 3 square. So it is minus I cap plus 2j cap plus 3k cap divided by under root of 14, which is option 3. Next is question number 25. If a force on a rocket having exhaust velocity of 300 meter per second is 210 Newton, then the rate of combustion of the fuel is. So dm by dt into velocity is equals to force, that is 210. So dm by dt will be 210 divided by 300, that is equals to 0.7 kilogram per second, which is option 1. Question number 26. Two blocks are in contact on a frictionless table. One has mass m and other mass 2m. Force F is applied on the 2m as shown in the figure. So acceleration will be F upon 3m. Normal force between 2m and m in this situation will be m into a, that is equals to F upon 3. In second case, we are applying this force on small m. So acceleration will be again net force divided by total mass, but normal reaction will be 2ma, that is equals to 2f by 3. So ratio of the normal reactions in the two cases will be 1:2. So correct answer is option 2. Question number 27. A body of mass 5 kg is suspended by a spring balance on an inclined plane as shown in the figure. So force applied on the spring balances. So this force will be mg. This will be mg sine theta. This force will be mg cos theta, and this will be normal, and this is kx. So basically spring force is balanced by mg sine theta, which is mg sine 30 degrees. So mg by 2. So it will be 5 into 10 50 by 2, that is 25 Newton. So correct answer is option 2. Question number 28. Two masses 10 kg and 20 kg respectively are connected by a massless springs like this. 10 kg is having an acceleration of 12 meter per second square. We need to find the acceleration of 20 kg. So for 10 kg, kx force is responsible for providing acceleration. So kx will be 10 into 12, that is equals to 120 Newton. For 20 kg, 200 Newton is in this direction and kx will be in the backward direction, 120. So net force will be 200 minus 120, that is 80 Newton, divided by mass of the block will give you acceleration, which is 4 meter per second square. Option 1 is correct. Next is question number 29. A rigid ball of mass m strikes a rigid ball at an angle of 60 degree and gets reflected without loss of energy or speed. The value of impulse imparted by the ball on the ball will be. So if you make the component of velocity, so this will be v cos 60 degree, v by 2, and this will be v sin 60 degrees, so it is root 3 v by 2. Similarly, for outgoing velocity, this component will be v by 2 and this component will be root 3 v by 2. Now you can say that there is no change in velocity along the y direction, but the velocity is changing along x-axis. So there will be net change in momentum along x-axis only. So it will be equal to impulse imparted, that will be m v by 2 minus of minus v by 2, that is equals to mv. So correct answer is option 1. Next is a balloon with mass m is descending down with an acceleration a. How much mass should be removed from it so that it starts moving up with an acceleration a? So initially the balloon is descending with an acceleration a. So mg will be in the downward direction minus some point force upward thrust in the upward direction is equals to mass into acceleration. So r will be mg minus ma. Now I'm removing m dash mass from the balloon. So total mass will be m minus m dash. So m minus m dash into g will be in downward direction, r will be in upward direction, and acceleration a is in upward direction. So in this case you can write r minus m dash g is equals to m minus m dash a. We can put the value of r from this equation. So it is mg minus ma minus m minus m dash g is equals to m minus m dash a. After solving this equation, you will get the value of m dash as option 1, 2 ma upon g plus a. Next is, this is the system and the system is moving in the upward direction with constant velocity. So we need to find the net force on the block of mass 2m. So system is moving upwards with the constant velocity, right? So net force on the particle will be 0. Why? Because if it is moving with uniform motion, then acceleration will be 0. So correct answer is option 1. We have magnitude of a vector plus b vector is equals to magnitude of a vector minus b vector. So you can write it as square root of a square plus b square plus 2ab is equals to square root of a square plus b square minus 2ab. Square on both the sides you will get 2ab is equals to minus, this is cos theta, this is cos theta. So it will be 2ab cos theta is equals to minus of 2ab cos theta. So you'll get 4ab cos theta is equals to 0. So cos theta will be 0. So theta is 90 degree. So correct answer is option 3. A car runs along a horizontal path with velocity 20 meter per second. The driver observes the rain hitting his car at an angle of 60 degree to the vertical. So this is the velocity of rain with respect to car, velocity of rain with respect to man. If the rain is actually falling vertically, the speed of the raindrop is nearly. So basically, in this triangle, you can see that tan theta is perpendicular divided by base. Perpendicular is 20, base is VR, and tan 60 degree will be root 3. So VR will be 20 by root 3, that is equals to 11.55 meter per second. So correct answer is option 2. Question number 34. River is flowing due west to east at a speed of 5 meter per minute. A man on the south bank of the river capable of swimming at 10 meter per minute in still water wants to swim across the river in shortest time. So time is given by d, where d is the width of the river, divided by u cos theta. So if you want this time to be shortest, u cos theta should be maximum. That means cos theta should be maximum. Cos theta is maximum when it is 1 and it happens when angle is 0 degree. So person should start directly like this, right? So this should be the direction of motion of the person from this point. So it will be due north. So correct answer is option 1. A body A is going from south to north. This is east, west, north, south. Uh, so south to north, this is the direction. Velocity is, let's say, v j cap, and another with from west to east. So velocity is v I cap. Then direction of relative velocity of A with respect to V will be. So it will be V j cap minus V I cap. So this is V and this is minus V I cap. So the resultant will be this one, and it is along northwest. So correct answer is option 1. Two spheres of the same material have radii 1 meter and 4 meter and temperature 4000 Kelvin and 2000 Kelvin respectively. So energy radiated per second by the first sphere is. So energy radiated is directly proportional to energy radiated per second is directly proportional to area into temperature per 4. So area is directly proportional to radius. So you can write it as Q1 upon Q2 is equals to A1 upon A2 into T1 upon T2 power 4. A1 will be 1 upon 4 will be square 4 square because A2 is directly proportional to radius square into T1 upon T2. So it will be 4000 Kelvin divided by 2000 Kelvin to the power 4, right? So this will be 2 to the power 4 is 16. So Q1 upon Q2 will be 1. So it will be equal in both the cases, which is option 3. Next is we have a mass. It is hung from this uh, string. We need to find the tension in the horizontal string. So let's say this is T2. So this tension is T3 and T3 is equals to mg. So for this point, if this point is in equilibrium, this is 30 degrees. So T1 cos 30 degree, that is T1 root 3 by 2 will balance T2. And T1 sine 30 degree, that is T1 by 2 will balance mg. So T1 is 2 mg. So T2 is 2 mg into root 3 by 2, that is root 3 mg. So correct answer is option 2. Next is we have a block of mass small m and it is placed on a smooth inclined plane of inclination angle theta. The wedge is given an acceleration a towards right. We need to find the relation between a and theta so that block remains stationary on the wedge. So this will be mg. This is normal n. This component will be n cos theta and this component is n sin theta. And if you observe everything from this wedge, this is non-inertial frame of reference. So pseudo force will be backward ma. So basically ma is balancing n sin theta according to this frame of reference and mg is balancing n cos theta. So when you divide these two equations, you'll get a is equals to g tan theta, that is equals to option 4. Question number 39. A truck traveling due north with 20 meter per second turns west and travels with the same speed, 20 meter per second. What is the change in velocity? So basically 20 j cap is the initial velocity and minus 20 I cap is the final velocity. So change in velocity will be final minus initial vector. So it will be minus 20 in this direction and minus 20 in this direction. So the resultant will be this one using parallelogram law of vector addition. That is equals to under root of 20 square minus 20 square minus 20 square. So it will be 20 root 2 and this direction will be west south, southwest direction. So correct answer is option 1, 20 root 2 in southwest direction. Question number 40. A ball is projected from the ground at an angle theta with the horizontal. After 1 second, it is moving at an angle of 45 degree. So velocity at any instant of the projectile motion is u cos theta I cap plus u sin theta minus gt j cap. So it will be u cos theta plus I cap plus u sin theta minus g j cap because time is 1 second. Now the angle between the velocity in the horizontal direction at 1 second is 45 degree. So basically u sin theta minus g is equals upon u cos theta is equals to tan 45. So it is 1. So u sin theta minus g is equals to u cos theta. After 2 seconds, it moves horizontally. That means only horizontal component of the velocity is present. So 2 seconds is half of the time of light. So half of the time of light is u sin theta upon g, that is equals to 2. So u sin theta is equals to 2g. So if you put the value of u sin theta in this equation, you will get u cos theta as g only. Fine. So what you can do is you can square the equation 1 and 2 and you can add these two equations to get the value of u. So after squaring and adding, you get the value of u as 10 root 5 meter per second, which is option 3. Question number 41. We need to find the acceleration of this arrangement. So net pulling force will be mg divided by total mass of the system, that is equals to m plus m dash. So this will be your acceleration, which is option 2. Question number 42. Ball of mass 0.2 kg is thrown vertically upwards by applying a force by hand. If the hand moves 0.2 meter while applying the force and the ball goes up to 2 meter height further, then the magnitude of the force is. So basically work done by this force is converting into the potential energy of the block at the highest point. So work done by this force is F into 0.2 and that is equals to mgh. So it is 0.2 into 10 into h will be 2.2. So force will be 22 Newton, which is option 2. The time taken by a particle to slide down a smooth inclined plane is double the time it would take in falling down through a height equal to the vertical height of the plane. The inclination of the plane with the horizontal is. Let's say this is the plane, this is the inclination angle theta, right? This is the height and this is L. So in this case, time taken is 2 times the time taken by the particle in dropping through the same vertical height h directly. So if this time is t, then it is under root 2h by g. Time taken to fall from this to this will be 2t, that is 2 times under root 2h by g. Now this time taken is also equal to what? Is also equal to under root 2h upon g sine square theta. Right, so if you equate this value, you'll get sine theta is equals to 1 by 2 and theta will be 30 degree, which is option 1. Question number 44. The change in state of gas from A to B as shown in the figure, the work done in this process is. So work done is equals to area under this PV diagram. So after calculating the area, you'll get your work done as 12 into 10 power 5 joule, which is option 4. Next is question number 45. We have a 4 gram of helium at 27 degrees Celsius and we have a 16 gram of O2 at 37 degrees Celsius. We need to find the temperature of the mixture. So temperature of the mixture will be N1CV1T1 plus N2CV2T2 divided by N1CV1 plus N2CV2. When you put the value of N1CV1 T1, N2CV2 and T2, you'll get the temperature of the mixture as 31.5 degree Celsius. Question number 46. The rise in temperature when an ideal monoatomic gas at 27 degrees Celsius is compressed adiabatically to 8 by 27th of its original volume is. So we have adiabatic process. So we have Tv to the power gamma minus 1 is equals to constant, right? And we have a monoatomic gas. So gamma is 5 by 3, right? So we can write T1, V1 power gamma minus 1 is equals to T2, where V2 power gamma minus 1. So T2 will be T1 V1 upon V2 power 5 by 3 minus 1, that is 2 by 3. So V1 is V, so V2 is 8 by 27 of V, right? T1 is 27 degrees Celsius, so it is 300 Kelvin and it is V upon 8 by 27 V power 5 by 3 minus 1. So after solving this value, you'll get T2, right? And that is 675 Kelvin. So change in temperature will be, you'll have to convert this into degrees Celsius and you'll have to subtract it from 27 degrees Celsius. So you'll get your correct answer as option 2, that is 375 degrees Celsius. Question number 47. A body cools from 80 degrees Celsius to 40 degrees 64 degrees Celsius in 5 minutes. And the same body cools from 80 degrees Celsius to 52 degrees Celsius in 10 minutes. What is the temperature of the surrounding? So for that, I'll use theta 1 minus theta 2 divided by T is equals to K theta 1 plus theta 2 by 2 minus theta naught, where theta naught is the temperature of the surroundings. So it will be 80 minus 64 divided by 5 minutes is equals to K 80 plus 64 divided by 2 minus theta naught. This is my equation 1. Next is 80 minus 52 divided by 5 is equals to K. So it is 80 into 80 plus 52 divided by 2 minus theta, this is 10 minutes, theta naught, this is equation 2. After dividing equation 1 and 2, I'll get my answer as option 1, that is 24 degree Celsius. Question number 48. A slab of stone of area 0.36 meters square and the thickness 0.1 meter is exposed on the lower surface of steam at 100 degrees Celsius. A block of ice at 0 degrees Celsius rests on the upper surface of the slab. In 56 minutes, 4.5 kilogram of ice is melted. The thermal conductivity of the slab is. So basically, heat required is ml, and that is equals to Ka delta theta divided by L, right? So what you can do is, this is delta Q by delta T, and this delta Q by delta T will help you in melting, right? This is delta Q by delta T, right? So you can write delta Q is equals to ml. So after that, K A delta theta upon L is equals to ml upon delta T. So K will be ml into small l, that is the length of the slab, is upon delta T into delta theta into A. So after putting the value of mass, latent heat, length, change in temperature, time and area, you'll get the value of K as 1.33 as option 3. Next is question number 49. Figure shows a conduction rod of non-uniform cross-section. The ends of the rods are maintained at constant temperature 100 degrees Celsius and 0 degrees Celsius respectively. At steady state, the temperatures of PQRS are TP, TQ, TR and TS respectively. Then, which of the following relation is correct? dq by dt is equals to constant and it is equals to Ka delta theta by delta T, or K delta theta upon L, right? Now this value should be constant. That means if K and L is constant, then A delta theta should be constant. But A is decreasing. So in order to keep this term as constant, delta theta should increase, right? That means TR minus TS will be more than TP minus TQ, which is option 3. Next is heat is supplied to two solids at constant rate and their temperatures are plotted with time. Then which of the following relation is true? So we have heat supply rate as constant. Let's say it is alpha. So basically we have delta Q by delta T is equals to alpha. So delta Q is equals to, let's say, alpha delta T. Okay, or you can say alpha T when T is the time. Now this alpha T is equals to ms delta theta. So S will be alpha T divided by m delta theta. Now for this two solids, you can see that alpha upon msa will be greater than alpha upon msp, right? Okay, by looking at the slope, you can write it as alpha upon msa is greater than alpha upon msb. So SA will be less than SB, and clearly MLB is greater than MLA. So LB is greater than LA. So correct answer will be option 3.